So today we are going to talk about two concepts in a Postgres database. They're not used often and they're kind of confusing, so we're going to go through it slowly and write some SQL real time to make it more understandable. So the first one is window functions. Window functions are odd. They perform a calculation across a set of table rows that are somehow related to the current row. This is all definition stuff. We'll read it and then we'll talk about it. This is comparable to the type of calculation that can be done with an aggregate function. But unlike regular aggregate functions, the use of a window function does not cause rows to become grouped into a single row. The rows retain their separate identities. Behind the scenes, the window function is able to access more than just the current row of the query result. What the heck does that mean? I'll show you what that means. So let's imagine we have a database of employee salaries. I'll put that into my database. Now I have a database of employee salaries. How will I get the average salary for all my employees? That's an interactive question. How would I get the average salary?
AVG. Average salary. Yeah.
Okay, so now I have my. Whoops. What did I do? Did I type something wrong?
You left out from.
From. So our average employee makes 4,710, whatever. That's easy. So what we can do is we can start to perform aggregate functions across the data set without grouping. So if I wanted to find the average employee salary from my developers, or by department, I would select average salary from, or select department and average salary from employee salary, grouped by my department. And that's what we would expect. How would I get the employee number, the employee identifier in this query? But still retaining the same data.
Really put in an array of all the.
Can you not just do select department, employee number, and average salary?
Good. And Greg, I heard what you're going to, and we'll hit on that in a second. Select employee number, department, average salary from employee salary group by department. Who knows what's going to happen when I press go?
You're gonna get a lot of the. You're gonna get each employee number and then a lot of the same. I don't know.
Good guess. It's not going to work
Yeah, that's.
because I have to group by the employee number. So if I do that, if I group by the employee number as well, it's not exactly giving me what I wanted it to do. It's basically grouping by employee number and department, and then for every combination of that, getting the average. Well, in this case, the employee number is unique, so there's no grouping by that employee number, right? Yes, Professor, you're right. Cool.
Yes, Professor.
So how can I?
Prime Day right now.
Oh no! Don't get distracted by buying cheap TVs. They didn't have any good ones, or I would have bought one. Tell me, somebody's got to be able to figure out how to make this happen. How can we make this happen? without using the cool functions I'm about to teach you.
So your end goal is just to have the employee number in your salary? I mean, like in your average salary table?
Yes, here's what I want one of my results to look like. I'm looking at the last line, for sales, and then the average of their department. Like I like this query. Sales 48, 66, 67. That's what I want in one of my results.
That's where having comes into play.
I'm not saying like that would be if you want to be on the backer side.
I'm not sure about this, but I think we can use the where clause.
That'd be another row. The where clause. Tell me more.
Select department average from so and so where. I think then we need to give a constraint.
Yeah, and I don't know what constraint to give.
I think whatever Jess's answer is going to be is probably the right.
I know. I'm kind of waiting for her to answer.
No, I'm trying to think why you would want to. I do not know. I do not know.
Here's why I would want to know.
Something to select.
Here's why I would want to know. I would want to know the employee number, the average salary in their department, and their delta in standard deviations over time. That's eventually what we would want to get, right?
Maybe we can use nested queries, like as she said, we can use select blah blah blah, where salary, then we can calculate the average salary, right?
Okay, now you're getting somewhere. At least that's what I was thinking. I'm sure there are other ways to do this. Jess, have you ever used a window function?
I have not, but I do agree with that solution of creating a column that has the average
Yep.
and then a difference from.
Exactly. So how would we do that? We would do, and this would be a subquery. So we would want to select, let's call this department 2.
Professor,
Yep.
in that salary, why are we getting that precision and scale for so long? Can we reduce that?
Yeah, I'm sure we could. I'm sure we could. There's a rounding
Yeah.
function. What is it?
Yeah,
Round.
it's like disturbing with so many zeros.
Is it bothering you? I think I can do. Let me test that real quick. I think that's what I would do. There we go. I'll do that. Okay.
Yeah,
So I want the employee ID. Right? Was that my field? Employee number. Okay. Employee number, their salary, and their department, and the average salary from employee salary. How do I do a subquery?
And you can say where employee salary or average salary equal to average salary.
That's where department equals DT2. And I think this is my... See, now I have to Google this. I hate syntax of different things. There we go. Okay, cool. There we go. That's what I need to do. Oh, that's not what I want to do. See, I feel like I want to be doing an inner join, but I want multiple columns back.
Can you split your screen so we can still see it?
Yeah, I can do that. Let's see. I'll do it this way. Go left and give me you on the right. Can you kind of see that? And let me get rid of
that's
it.
perfect.
Let me try to get rid of this thing. Inner join on. No, I don't want that. I don't want exists. See, this is kind of what I want. That's not, I need a query as like a temporary table. How can I do that? Query as join table. Ooh, let's see if that works. Query.
Didn't you also just create a table of the averages and then reference that table?
Yes.
And join?
I could do a view. Why don't I do a view? That would make it easier. I need these words to wrap. Let's see if I can go that way a little bit. I don't need this window now. I don't need the other one. Let's create a view. So that's that. Okay, I've got my view. Select star from, just gonna make sure it looks like I think it should. There we go. Inner join average salary on employee number equals, oh nope, that's not right.
Department.
Yep, department equals D2, DT2.
And don't you want to reference the average salary from the view?
The average salary column will be from the view.
Okay. You don't have to do aliases or anything? It just like intuitively knows you mean that?
I aliased it when well, they're unique column names. So on my employee salary table, it's called salary. Okay. That's one way of doing it. So I think that gave me the data I wanted. So I have employee number, their salary, their department, and the average in their department. Then if I wanted to calculate the differences, I could say employee 7 makes $820 less than average. Employee number 3 makes $300 or $520 less than average. All right, that's putting us in the right direction. A different, I'm not going to say better way, I'm going to say a different way of doing that is called a window function. So I'm going to copy this over and talk about it in SQL Developer. So if we look at this query, you can see I'm using an aggregate function without any group bys. So I'm selecting department, employee ID, that person's salary, and the average salary. Let me make this easier to read and understand. This is all one thing. This is one statement. I'm also selecting the average salary over the whole result set partitioned by department, basically grouped by department. So what this one line of code does is it calculates that average salary on essentially a group by department, and then automatically ties it back to whatever that department is for that row. So when I execute this, I get the same results I got before. Kind of cool. Kind of cool?
Yes, quick question.
Yep.
Can you go back to the partition? And then so it starts from partition and then over and then average? Like
Yep.
How you can interpret that?
Yeah,
in
so
that word?
so let's think about order of operations, because I think that's going to make it a little easier to understand. When we do a query, the first thing that the database engine does is it says, okay, what table are they looking at? Okay, what table are we looking at? And they get that, the database engine gets that from using the from keyword. The second thing it does is it does any joins, so that can add extra tables. That's irrelevant in this query, but that's kind of the next step. Here's an important part. The third step is to filter the results. This is our where clause. Usually I whiteboard this, but this is working. Is this working? So the third thing the database engine does is it evaluates that where clause. What that does is it takes your full data set from the table and potentially limits it to a subset. Right? That subset can be of size 0 to n, where n is the size of the full set. After that, it'll do a group by type statement to collapse multiple rows together conceptually. Like when we group by state, we are now collapsing all those into one subset, one atomic subset of the big set. Then it performs any aggregate functions, average, sum, count, etc. Then it'll do a having filter, because it needs the value from the aggregate function to be able to perform the having. I'll stop there because this is the important part. The aggregate functions are performed on a group. Right? A grouped set of rows. In this query, we are performing an aggregate function. But instead of performing the aggregate function on a group of rows, well, on a collapsed group of rows, we are still performing the same aggregate functions on that identified commonality, in this case, the department. So this is just like doing a group by, but without collapsing the rows, except to calculate whatever the aggregate function is. In this case, it's average. So this...
Oh,
go on.
I'm sorry. Oh, I'm sorry. Go ahead. I'll ask later.
Okay, so in this example, I am partitioning by department. I don't have to partition by anything. In this case, I get the average on the whole table. This allows me to do this without grouping, making a view, joining, subquerying, all that kind of stuff. It's calculating a running average on all the rows that passed the where clause. And it gives you access to that aggregate data in your result set. I guess the key point there is return the result set.
So this wouldn't work if over wasn't there, right?
Correct. If over was not here,
I've never.
I haven't either until I start teaching this. It won't let you do it because you're not grouping by. Whoops. It's pretty awesome, isn't it? Think about what you...
I want to go test this.
I know. Think about what you can do, though. Here I'm doing a silly thing about department averages, right? But imagine you can do things by time. You can perform a query where you're getting running totals on a month. So sales numbers as a percentage of that month's sales. Trend lines. I mean, there's a lot of cool things you can do with this kind of a function in a pretty simple query. Where was I before I took out the over? It was partition.
You run that query again without the partition.
Yep. I'm just putting the partition back in there so I make sure I do it right. Oh, it's not partition on, it's partition. I always add words because that's what I say in my head. Oh crap, what did I do wrong?
Partition by.
Partition by, thank you. Okay, I had the wrong words in my head. And then without the partition,
What does that number stand for? The 4710. Is it the average of the whole database, like across the table?
it is, yeah. It is. So it's the same. It's the same as if I just run. I thought I still had it. Select average salary from employee salary. So 4710. Run it here. Whoops. From. Gosh, I keep missing that. 4710. Now to show that it is result set bound, I can take the total salary to get the without partitioning, where employee number is less than 8. So if I look here, I see 5,200, 5,200, 45, 6,000. The total number is going to go down. It should go down, I think. So it filtered that result set in step 3, and then performed the aggregate window function on that filtered result set.
Chris, quick question.
Mm-hmm.
What does that parenthesis, open close parenthesis after over means in this case?
It's just an empty. Basically, it's a parameter to the function. It's empty. I don't think I can exclude it. I think I have to have it. Yep. So going back to the slides, that's one use. You can use any aggregate function here. This one's just using max instead of average. My title's wrong. But if I want to pull the maximum salary in each row, I can do that. Again, for clarity, this is one line. Oops. There. Max, min, average. Oops. Max, min, average.
So if you didn't have the partition by department and they were just over, and it would just give you the overall max salary like 10 times, overall min salary 10 times. Right.
Yep. So now I'm doing some analysis of what that data looks like in a single query. Do I need to make that bigger, Jess? I see you getting close.
And Professor, is there any other keywords that can we use for the over? I mean, instead of partition by?
Let's go through the slides and see what else I have in here. There's a magic function called ranking. Ranking function produces a numerical rank within the current row's partition That's the word I should use, partition, for each distinct order by value in the order defined by the order by clause. Rank needs no explicit parameter because its behavior is entirely determined by the over clause. Let's go to show you what that looks like. I think we'll get to that question in a second. But here I have, again, let me do it like this. I'm not returning a row, or I'm not returning a specific column. I'm returning the value of a function, just like current timestamp is a function. So I want the rank of this partition, so I'm still partitioning by department, and I'm going to order by the salary descending. So what question is this asking, or is it this answering, of your employee salaries?
It's finding the maximum and then the minimum, maybe.
Not kind of. Who's the top paid in my organization, in each department? Who's the lowest paid in all of my departments? So when I run this, I will see I now have a rank. So in my developer department, my highest ranked, my number one rank with the highest salary of $6,000 is employee number 8. Employee 10 and 11 are tied at second. So it's second and third, right? The next is fourth place, fourth rank, fifth rank. Then I go to my personnel department and I get my first and second. And I go to sales, I get my first and tied seconds.
I'm sorry, I didn't get it. Like, it's ranked based on what?
This clause here. Order by, then a column, descending. So this is the column, but this is basically a sub command or a descriptor for that rank function to tell it within the partition how are we defining our rank. And in this case I want to do it by salary. But I can change that to employee number if I wanted to. That doesn't tell you anything. But
So,
yep.
so when we run this query, the line number 8, the rank is the same, but the salary is different. The
Whoops.
first row is 5,200 and the other one is 5,000.
These two?
Yeah, no, the first row and the 8th row.
Oh, yes, exactly.
Both the rank,
Yep. So
each one is
the partition that it's calculating the rank on is the department. So within that department, what is the rank?
okay.
So if I took out the partition, the data would look very different.
So though the rank is the same, it's filtering on the department.
Not filtering. Partitioning is the right word, but it's almost like grouping. So a partition is almost a group.
So you'd expect to see a 1 for developer, sales, and personal, because each one is going to have a top salary.
That's it when I have a partition, correct. For partition by department. When I don't have a partition, now it's over the whole set of data. So I have a first, I have 2 seconds because they're tied. My fourth, fifth, 2 tied for fifth, 7th, 8th, 9th, and 10th. Because I'm not partitioning, I'm going over the whole result set.
Yeah, but
All right, so I think now after seeing that, the rows considered by a window function are those virtual table is a word that's in somewhere, but it is the word is really a partition in the result set. produced by the query's from clause as filtered by its where, group by, and having clauses. For example, a row removed because it does not meet the where condition is not seen by the window function. That was step 3 or whatever it was. A query can contain multiple window functions that slice up the data in different ways by means of different over clauses, but they all act on the same collection of rows defined by this virtual table. That goes back to this query, where we wanted to get the department's max, min, and average, max, min, average, but we also wanted to get the overall max, min, and average. Max, min, average. It's all dependent, though, on the things that are filtered or not filtered in the where clause. In this case, there was no where clause, but again, if I add one, my numbers are going to change. So you see my max there, my overall max, or sorry, average was 4366 when it was filtered. When it's not filtered, it's 4700.
Okay, I have a question. Maybe it's a silly question.
No such thing.
When you okay, so when you run the last query, when you rank the average salary, there was only 1, 2, and 4, 6, 7 like this, and you skipped 3. Is it like taking the salary, find the max, then create like a window, partition the salary based on this window, and then assigning each salary to sub partition or whatever?
Yep.
How is it working?
Yeah, that's exactly right. So imagine you're at a track meet, right? And you're watching some people run a race. If you have 5 people running the race and the first one crosses the finish line, then the next 2 cross instantly at the same time. There's one first place, but then the next 2 people came in second place. They tied. Traditionally, in that example, no one gets third place. It goes to fourth place. And that's what this partition does as well. So you'll see the first one got first place. The next 2 got second place. They tied for second. Right, because they have the same salary. And then the one after that is fourth.
Got it.
So there really is no third place. So I think the way you can talk through it is that this row number 4, happens to be the 4th highest paid person in the department. These 2 rows are the 2nd highest paid people in the department, and this one is the highest paid in that department.
Got it. Thanks.
You're welcome. All right. So, why did I do that? Okay, we did this already. We talked about it. Salary descending. Oh yeah, so this is just ordering our query, a regular query, to give us the whole data set in a way that we can visually collapse it in our heads. Because here we're going to eventually, when we do these window functions, we'll window on this department. This is our first partition. Because these all have, when we've used the partition over the department, this is our first partition. The 2 personnel folks are our second partition, and the 5 develop folks are the third partition. We already talked about this. Yeah, so just more of the same. So summing, we can do the sum function on salary over the whole thing without a partition. Then we can order by the salary if we wanted to. Oh, this one's fun. Yeah, no, I like this one. So if we run this query, excluding that order by statement. We'll get to that in a second. So I'm selecting the salary and the sum of the salary over the whole data set from employee salary. So every row will have 47,100, because that's the sum I'm counting. If I put an order by within the over clause, something cool happens. I think this is cool. What's happening?
Oh, it's taking the next salary and adding it to the previous to do the sum. So it's starting with 3,500, and then the second one it's taking 3,900, adding it to 3,500. And that's the new sum, and it just keeps doing that.
Yep. So I'm getting a running total, right?
That's a good way of putting it.
So the last one is 47,100, which is the total sum. But when I have an order by, it does that running total or something like that to show the accumulation up to that point in time. Does anything in the real world sound like it does that?
A list of sales.
Sales is a good one. What about your checkbook?
Well, that's more of a subtraction,
Yeah.
right?
Description. What would I put here?
-20.
I would want a date. I would want a timestamp of some sort. I'll just do the ID to make it easy. But yes. So this should give me a running balance of my account. Whoops, I didn't run all that. Whoopsie. Oh, what did I do wrong? Select, description, value, sum of value over order by ID from transactions. Semicolon. See these double quotes? They always get me too. That's my table there. Okay, my table's there. Insert my transactions. Good. So we have just done a super quick modeling of a bank account. Or a checkbook. Same thing. But I see something like this every time I log into Wells Fargo or Capital One or whatever. So there could be some cool uses there. What I think is really, really powerful is I can do all of these calculations at the same time. The first way we did this, I'd have to create either a subquery or a view for every one of those rows, every one of those columns to join to. I think. No, I could get away with 2 views, but still. A view per partition. Yeah, that's what I'd have to do. All right. Any questions about that? Yes, I will save this SQL and put it on the website.
Sound good.
I got one good.
Good.
Cool. Have we talked about JSON at all? Please remind me.
Nope.
Not really.
Not really, no. Okay, cool. Good. JSON stands for JavaScript Object Notation. Is anyone familiar? Has anyone done any web development or front-end development or any data migration using JSON?
So we use JSON for the our Power BI reports. Like if we want to use the same McKesson colors and the same theme, anytime we make a dashboard, we'll load the JSON file and it'll change all the colors and all the formatting to keep it consistent.
Perfect.
Beautiful.
It is used a lot for configuration. The format itself is used a lot, but for things like configuration, because every programming language in the universe knows how to deal with, parse, process, and store data into and out of JSON. It's a nice, lightweight format for storing and transporting data. Often used on web pages. It's self-describing, and that's the key that makes it so easy to use. So here's an example. So let's say we have this JSON object. JSON objects or JSON documents, I can say, are just text documents. It's just textual content. And so in that textual content, there's a format for how we represent things. An object is surrounded by curly braces. And if you've done any object-oriented programming, you know what an object is. In our database class, you could think of an object as a row in a table, as an example. Right? So the row in the table has attributes or fields. So in this case, I have 2 types of objects. Well, 3. One is the outermost object that stores data. Inside of that, I have one attribute called employees. So attributes are keys, or they're always a string data type, but it's a key describing what the value is going to be. So this is your column name. This is your, in this case, we could look at this almost like a table for employees. And inside of that table, I have an array. The array is square brackets. Within this array in particular, I have 3 objects. So if we think about this whole thing as kind of a wrapper for my employees array, or we could call it a table if we wanted to, because you would typically take this and load it into an employees table or something like that. And each of the objects in that employees array has 2 attributes. One is first name and one is last name. Attributes are always paired with a value, and you'll see that with the colon. So my employees attribute, the value is the array, is an array. The first name attribute on the first object's value is John. The first name's value on the second object is Anna. Third is Peter. Last name, same thing. I've the last name and the value, last name and the value, last name and the value. This is what it means by self-describing. If I did this in a, oops, where'd my SQL developer go? Let me do a quick file. In a CSV, that's that's whatever. This is a SQL file, but I'm going to put CSV in it. If this were a CSV, I would say John Doe, Anna Smith, whatever the values were, right? You have no, looking at this, you might be able to guess at what the data means, but you can't tell for sure. Right? It could be somebody's first name and their favorite animal. A female deer. Doe deer. Right now. First name and the street they live on. We don't know, right? Because there's no context. This goes back to the whole data versus information thing at the beginning of the course. This is data with no meaning. Once we give it some structure or metadata, it has meaning. Now we know this is a first name and a last name. Everybody with me so far? This is
Yep.
totally intended to be a new concept, so I fully expect lots of questions. If you ask them, great. If you don't, okay. JSON only has 5 data types. 5. An object is a data type. An array is a data type. We have strings. We can have numbers. And we can have booleans. True or false. That's it. There's no date data type. There's no difference really between a float and an integer. There's nothing else. Those are all the data types. And that's okay. It's simple. It's intended to be simple.
Chris,
Yes, sir.
what's array by the way here?
What's what?
What's the arrays? The array.
That's the array.
So that's the square bracket is array.
Yep. And then
Everything including.
inside the square bracket,
Uh-huh.
in this case, I have 3 objects. They're separated by commas. I could have 3 numbers. I could have 3 strings. I could have 2 numbers, 7 strings, and a boolean. It just has to contain something. In this case, it contains 3 objects. Good question. All right. Postgres can natively give you a result set in JSON. There's a function, row to JSON. So if I execute this query, I'm going to do two database files just to make life a little easier when I upload them. So I'm just going back to the structure of our select statement. I'm selecting from my employee salary table. I have no filter, I have no where, I have no group by, I have no nothing. The syntax for this function, row to JSON, takes the table name from my query. And for every row in my query, it's going to turn it to JSON. So when I run this, my result is 10 lines of JSON.
Well, Professor, why do I need to do this? Like, how I'm going to use it?
So, one very common way of transferring data from one application to another is via JSON objects. You could take this output and feed it directly to a web page. Well, the web page would execute a query and get JSON, so it natively could deal with it in JavaScript. If you wanted to my phone just started talking to me. If you wanted to get data out of your Postgres database and load it into Redshift or Snowflake or another database engine, JSON is a good intermediary format.
Okay, got it. It's like XML, but in databases, right?
JSON is not a database thing. So let me clarify that though. JSON started as a way of transporting data for web pages. So if you're familiar with like how a dynamic web page can make an API call to get data, to update your map or to show your shopping results, it'll make an API call to the data, to a web server, and the result will be JSON, so it can deal with it, so it can parse it. That's where it started, and that's why it's called JavaScript Object Notation. Then the database creators like Postgres said, well, this is a very common format. I'm going to make it easy for for developers using my database engine to get their data in a JSON format. Like XML did not start as a database thing either. It was another transport mechanism or transport format of data. But then database engines said the same thing. They said, ooh, a lot of people use XML. Let's figure out how to make that work in my database. I hate XML, so I won't show you XML. But yes, it's very similar to XML, but it's not, I wouldn't say it's database centric.
Well, thank you.
You're welcome.
It's pretty simple too when you're using Python, like the data frame. You're uploading it as a data frame. It kind of structures it very simply. You don't have to do a lot of extra steps.
Absolutely. So here's one thing I was curious about as I was reviewing my slides for tonight. So I have a query. I'm going back to the other side just so I can take this query. I want to run it. So this is the query. Like this is this first line is just going to give me every row in the table. This query is one of my fun ranking queries. It's going to rank my associates in the whole database. But let's partition by department. Make sure I get the data right. Whoopsie. Why am I doing this? Oh, because I can't spell partition. Okay. So I wonder if I can make that JSON. This is really me trying to figure something out. So I'm curious if I can quote or put the whole thing in that row to JSON format. No, I can't do that. Oh, okay. Character varying integer big does not exist. Let's try something else real quick. Because I know I'm returning the same data, so this has to work. Select T from subquery. I think this is how I want to do a subquery. As T. Maybe? There's got to be a way to do this. Hey, that worked. Look at that. All right. So here, that's how you do a subquery. My subquery is the data I really want. Right, I really want my department, my employee number, my salary, and their rank. That's the stuff I want. But I want to see it as JSON. So what I did a subquery. You can see the start. Did the blue show up for y'all? The start and end blue parentheses?
Yeah, we can see it.
Okay. I can also make this like this to make it really easy to see. There we go. So this is the query I wanted. I'm making it a subquery and I'm aliasing it as T. That can be anything. And then my row to JSON is T. So now I've taken whatever query I want and turned it into JSON. So that tells me anything I can turn into a query, I can turn into JSON. Okay, so that's cool. What else can we do? Row to JSON with specific fields. Oh, okay, this would have been another way to do it. See if I'd looked ahead. So row to JSON. Here I am explicitly creating a row data structure in the database engine of the 2 columns employee number and salary. From employee salary, limit 3 for fun. And there's my 3. Interestingly, it didn't give it a name, F1 and F2. Also now, can I do that up here as well? Can I take that, row to JSON, and around the whole thing? Does that work as well? Oops. Select row to JSON. Oh, I need one more. Yep, I needed one more. There we go. Okay, I like my first way better because I have my column titles. I like my subquery. Hey, look, I did get ahead of myself. So that's what we ended up doing. That's subquery.
I'm sorry, F1, F2, where these come from?
So when I do this, let me clear that and run it again. So I can have my query select employee salary from employee salary. But to use this row to JSON structure, I need to basically create a row object in my result set. So instead of individual fields, I now have a single row with 2 attributes, the employee number and the salary. But when I do that, I end up with this F1 and F2.
It's like frame 1, frame 2, or what?
I guess.
Okay.
I can't alias that, can I? That seems very weird. Yeah, okay, I guess it doesn't like that. So that's where I ended up doing this subquery. So my subquery returns department employee number, salary, and rank. And then that is essentially a temporary table, which I'm calling T from this temporary table, row to JSON. And if I do that, then my result set has the right column names. But in its simplest form, we can just select the whole table. So the employee salary table. So this one has a whole bunch of aggregations. I'm selecting employee number and salary to JSON, row to JSON, array aggregation. Oh, it's turning it into an array. Okay, let me show you what that is. So I do this in 2 forms. I'm going to take away the array aggregation. Oh, here we go. Row to JSON T. Okay. So I'm going to execute this, and I get 10 items in my result set. These are 10 objects. If I look at this as text, I get 10 lines of text. Right? I'm watching our time. We got a couple minutes left. So I'm going to go back up to my JSON. I'm going to say, well, I want an array because I know I can have an array data structure. When I'm using a language like JavaScript to parse this, these 10 lines as 10 lines of data is not a valid JSON document. It is 10 lines of individual JSON documents. So my code would have to parse line by line. What I can do, though, is use another function within Postgres to say, I want it all out as an array. So this all looks the same. My row to JSON in the middle. I'm going to aggregate it as an array. This is a database array. And then I want to turn my array into JSON. So before I run that, I want to do it step by step. Because I actually don't know what's going to return, what's going to happen if I take away this outermost array to JSON. So I'm array aggregating my rows to JSON. I think it's going to return, I don't know what it's going to return. We'll see. A string that doesn't make, I don't know what the heck that is. It's a big old encoded JSON string. Well, no. Something like that. Anyway, I can run the array to JSON and I get a proper JSON array. So that, yeah, that's an encoded string. And this is just a JSON string or JSON array. And so if I loaded this into my application, it would natively turn it into an array object or a list object, whatever language you're programming in. All right, there's some cool stuff that we'll talk about on Thursday on storing JSON documents in a database. Not breaking it apart and putting it into individual columns or rows, or sorry, columns, but storing the actual JSON object, and we can then manipulate the JSON object. It's kind of neat. But we'll do that on Thursday.
Okay.
Any questions before we boogie?
I'm good.
Good.
All right. I will. Yep.
One question.
Yep.
To give you a write-up by this weekend, if we give, is that okay?
Oh yeah. Your whole package is due on November 11th, I think. Whatever date is in the document. I think it's November 11th.
Yeah. And
But-
along with that,
And say if you want me to review your story or anything before that, just send it to me in email, and then I'll get to it either that day, the day after, or 2 days later. Sorry, folks, when it took like 3 days. My bad.
And the story supposed to be up to 2 pages, something like that. Minimum of 2 pages or up to 2 pages?
Up to 2 pages. I don't want to read that much more.
I don't blame you.
How much
Only
do you
the
want to
story?
settle for?
Come on now.
Professor, only the story up to 2 pages?
Correct. Yeah, the whole deliverable, like the final deliverable, you're going to have the story, you're going to have your ERD, you're going to have your ERD with attributes, you're going to have your SQL to create the tables, your SQL to insert data, and your SQL to query your data. So if you ended up putting that all in a PDF, it's probably upwards of 10 pages.
Okay. Yeah, okay, Professor.
Are you,
Patrick, go next, because you popped up first.
Are you posting other assignment links for the other pieces? I know you talked about that previously.
After class.
Okay, cool. Just wanted.
Yep.
Thank you, Professor.
You're welcome.
Yeah, good night.
Good night.
Thank you.
Thank you.
Thank you.